Cool. Let's do it, guys. All right. Okay, so we're still going back to Unit 2. There's a couple things I wanted to continue to go over, and there's just some great multiple choice questions, right? Oh, we got to roll through this quick. Here we go. All right. If some polynomial is x minus 1, x plus k, and the tangent line of the graph is parallel, then k equals. What the actual heck is this saying?
Tell your dad I said hi.
Okay.
Ben!
What?
No, tell your dad I said hi.
He knows my dad, so
Dad needs to know I said hi.
Okay, can we start with this equation? And it says that the tangent line is parallel to that. Now, what does parallel mean?
X will never cross.
Same slopes. What's the slope of this line?
-5 or -5.
Positive 5, but okay.
No,
If I just move the y,
is negative.
yeah, I know. But if I move the y over, it's Unit 2, page 3.
Sorry, I'm an idiot. Don't worry about it.
You're all right. So my slope of this line is 5. Or I can move the -5 and divide by negative, but my slope is 5, which means the slope of the tangent line of this, right? The slope of the tangent line needs to equal 5. Now, the way we find slope of the tangent line is the derivative. Can you guys take the derivative of this? Now, you could multiply this out, but I don't want to because then that puts k in 2 different spots. So I don't want to multiply it out. So if I'm not multiplying this out, what rule am I doing right here, guys? Product rule. Can we do product rule? Aw, how cute. You sit together. Okay, derivative of the first times the second plus the first times derivative of the second, right? So x plus k plus x minus 1 has to equal 5. You guys with me so far?
Yeah.
Because it's like the slope, the derivative has to be parallel to the slope, so it has to equal 5. Okay, but I still have too many variables. Any idea what I could plug in for x?
4?
Yeah, because it says it's at that point. So if I plug in 4 plus k plus 4 minus 1 is 5. So it's 8 minus 1 is 7. Let's freaking go, Andrew. K is -2. Favorite ever. Okay, thank you. We're just barely started. All right, you guys? There are 2 ways to do this question right here. Sorry, these aren't numbered. There's 2 ways to do that. All right, one way would be a quotient rule. If you like quotient rule, do quotient rule. What's another way that you could do that question? We're just finding a straight derivative. What's another way to do it? Bring it up. That's exactly right. So call it 3, 4 plus x squared to the -1 and do a chain rule. Okay? See if you guys can do it. Either way, I don't care. If you want to bring it up to the -1 or if you want to do a quotient rule, it's all good. Oh, so heavenly. Let's see. Okay, cool. Either way, so if I did quotient rule, the one thing I notice that people miss when they do quotient rule or something like this is they forget that the derivative of the top is 0. Like sometimes they put a 3 or sometimes they put a 1. If you are going to do a quotient rule, that's 0. So derivative of the top times the bottom, that whole thing goes to 0. Anyways, I get -6x. How do we feel about that? We feel good? Let's move. All right. Hey, this is like a calculator question, my friends.
That's kind of last.
Yeah, I'm thinking it's gotta be. Okay? Whenever you see something that's like messy, ugly like that, it's not gonna make us differentiate that. Heck no. Now, velocity is the derivative. So here's what I think we're gonna do. Let's go. Let me put my calculator in. Okay, let's see. So guys, let's go ahead and put the first equation in my y equals, which was what, cosine 2t. I'm just going to use x's, like, fine. And then the second equation in my y2, which is, what does it say, e to the what?
Wait, are we taking the derivative?
X minus 3.
Yeah, just hang on, hold your horses. E to the x minus 3?
And yeah, X parentheses.
Oh, good heavens. Yeah, or I could go alpha fraction.
Oh. No, it goes down, or else it would have an infinite number.
Like that?
It's not though, it's not.
And it's minus 0.75,
Oh, I did.
right? But yes, Randy, you're exactly right. We're doing velocities, and velocities are derivative. I just didn't want to take the derivative by hand, right? So I'm going to go, here's how you could actually do the derivative on your calculator. You could go math 8 dx of y1 at x equals x. And it will actually graph your derivative for you,
Wait, how'd you
which
get
is
to Y1?
kind of cool, actually.
How'd you get to Y1?
Oh, alpha trace.
Can you just put that in here?
Alpha trace. Okay, come over here now and look at this. Whoop. Okay. Yeah, and then I can do the same thing down here. And this is going to be derivative, so math 8. So d dx. y2, so I go alpha trace y2 this time. Oh crap, I put that in the wrong place, sorry. Alpha trace y2 at x equals x. So those are my two velocity equations. Now, when I graph this right now, it's like all over the place. Like, what the heck is going on? Right?
Turn some of those off, please.
Let's definitely turn some of those off. Let's turn off y1, and the way you do that is you go over to the equal sign and you push enter. And if I turn off y2, I go to the equal sign, I push enter. And that's the derivative. Those are the derivatives. Okay? Now, hopefully, did this question give me a interval?
Yes, they're.
Oh, bless. 0 to 2 pi. Great. Okay. I think I'm already on my Zoom trig. If you do Zoom trig, it's like 0 to 2 pi. Or you guys, you could just go window. And on my x's, I could just go 0 to 2 pi. So I see 1, 2, 3, 4. It does not look like they touch over on that side, right? I could like zoom in and
Try
make
it
sure.
anyway, and then the calculator
Well,
will
there's
just
no
hit the one on the right though, if it doesn't work.
Yeah, you're right. So, yeah, that's true. Yeah, so like if I were to try to calculate that, and I'm like, I wonder if those intersect right there. And I go like 1, 2, 3. They do intersect, but at a negative x coordinate. So yeah, that doesn't count. Okay? So they intersect 4 times. So we get to say that those intersect 4 times. Cool?
Mate, what time do you use to do Y1? Alpha trace.
Y1 was, yeah, alpha trace. very interesting question. Okay, well, I'm switching this back to regular mode. Guys, look at that question and tell me what you think. Okay, first let me ask you a question. This is the first thing I think of. Hey, if the derivatives are equal, then why the heck do I get two different values on my function?
One's got like a +1 or something.
One's got a plus c, that's exactly right. Well, like they both have plus c's, but where the integral is equal, so basically the graph of this would be f of x plus some constant. This would be g of x plus some constant. And that should be the same, right? But the constants could be different. In fact, they are. We can tell that they're different by, like if I'm plugging in 1, the constants are different. Okay? So what do you guys think? I don't think they intersect.
I don't think they can.
Yeah, they're not going to intersect. If you want to like think of an example, if you're like, I don't know, I don't understand this or whatever, think of an example. Let's say it was sine x plus 3 and sine x plus 4. So it would be like that, and that would be like that.
Hear me out. Hear me out. They're parallel.
Right.
The slopes are parallel at every point,
Right. So they can't be cut.
but they can't be the same line, or that and that would equal each other. So they can never intersect. I think that's good.
So you.
Ryan, we're finishing the one from last time, Unit 2, and
Okay.
then there's a Unit 3 one back there.
Sounds good, yeah.
Did we decide which one was 4?
Dang, this is tricky. Guys, we've got some tricky ones up in here. Okay. Wow, this is really tricky. All right, let's do this. The average rate of change. Now, before I look at that, can you guys just look at this real quick? And tell me what you would use for your formula for that for average rate of change. Okay? F of x minus f of 3 over x minus 3, and it gave me this. Which means, I gotta think through this, that f of x minus f of 3 is equal to that. Any ideas? I have an idea of what I want to do, but I want to see you guys think. Yeah, because I don't know what f of 3 is, right? Isn't that the problem? That's the whole problem. I don't know what f of 3 is. But, okay, since they both had an x minus 3, let's see if this makes sense. Then does that mean that f of x equals x squared minus x minus 6 plus f of 3? Is that cool?
Yeah.
So, I don't know if I want to do this. Oh no, we can't skip it. Okay, here's what I'm thinking, see if this works. Jacob, Henry, Zach, look for my mistakes, people. Ben, all you guys. Jacob, Henry, and Zach? And Raina, and everybody else?
Don't include.
Hold on. So, okay, if f of x equals x squared minus x minus 6 plus f of 3, that's true, right? So if I take the derivative, f prime of x equals all that. So if I plug in a 3, f prime, hold on, f prime of 3 equals 2 times 3 minus 1 plus f prime of 3, right?
Well, but the only problem is the function is divided by x minus 3, so it's not defined when x equals 3.
What?
Or else you're dividing by 0.
Yeah, you're right, but I think we're still okay. The function, no. The function can be defined, it's just that the average rate of change might not be defined. Okay? Well, look, just algebraically, if I add this over, if I add this f prime of 3 over here, what do I have right there? I have 2 f prime of 3's. Equals 6 minus 1 equals 5. So f prime of 3 would equal 5 over 2, which is an answer. Yay! What did I do wrong?
Wait, I've probably
Why is she-
being added, so you can't.
Yeah.
Six over 2. That's what I did.
What was that?
Oh, yeah, you added up, you did what I did earlier?
Oh, if I subtracted, it cancels out. Okay, so that's not good. Yeah, that's definitely not allowed. So does f prime of 3 have to equal 0?
If you have 6, I don't think you can just plug in 3. I think Jacob's right, because there's no answer for this.
Well, there's clearly an answer, though.
No, there is, but I don't think it's.
Yeah, do we literally just, I'll do this if it's this, do we just factor it and then plug it in? That sucks. Factor that out, so 3 plus 2 is 5. I don't know, it'd be nice if I had the answer somewhere. I do not.
Actually, yeah, that's probably just what you do.
It's probably that, huh?
Because the way we were doing it, that left it, so you got like,
F prime of 3 equals
you got 5 plus something equals that same something, which can never be true.
Right. Alright, I think that's right. I'll go look it up and see. Okay, this next one is a calculated question, guys. Okay, where do they have parallel tangent lines? So what would we do on our calculator? We would plug these in, right? Graph the derivatives, and then see what the derivatives are equal to each other. Yeah.
Yeah.
Now, what's kind of cool is that on my graph over here, I already have that derivative thing plugged in, so I just have to plug in y1 and y2, right? Okay guys, so I'm going to go over here, and I'm just going to clear y1 and y2 and type some new equations in here, right? So I'm going to leave the other stuff. So it's x squared minus fraction 1 over e.
plus 5 is bigger than just the derivative. E is the greater than symbol.
How do you do fraction?
Fraction. I don't know. I'm just doing.
Fraction is alpha y equals.
It's not, but it is. That's what it was.
And then y2 is just 2 squared root x. And again, I want to leave y1 and y2 turned off.
It isn't, but it is.
So guys, I can take the derivatives of those, but if it's a calculator question, I'm going to let my calculator take the derivative because, right? Oh, and then I need to reset this, you guys. How do I reset it?
Zoom 6.
Zoom 6. Very good, very good. Good. Zoom 6 resets it. Calculate, intersect. Enter, enter, enter.
Oh, yeah.
What the heck is going on?
How did you put that in?
Alright, let me try it again. Calculate, intersect, first curve, second curve, guess.
You just do that?
0.433. That's it.
Show me something like that.
Wait, what were the things she put in y3 and y4?
Yeah.
Okay.
So do I get?
Are we feeling, guys? Are we good?
It's still good. Stand.
Okay, I'm going to leave that plugged in because we're going to have more calculator stuff. I'm just going to keep moving this across the room, making our friends very dizzy. All right. Okay, guys, this is a no calculator question. Now, we in AB, especially you guys, we talked about this a ton today, yeah.
Well, when we do that?
I don't know, I factored it and canceled out the 3's and then plugged it in there, but I don't know that it's right. I gotta look at it and see.
Oh, wait, no, yeah. You were okay. I just got shut up. There's no more. There's no more.
Because the average rate of change should equal the derivative, but it doesn't always have to.
We're just gonna either currently.
Anyways, okay, so I'm not sure about that one, that's why I started. Okay, guys, we talked about f is increasing means what?
The slope is positive.
Yeah, so f prime has to be positive. So can you guys take the derivative of this, maybe with a product rule? Or I suppose we could just distribute it, but I think I'd rather do a product rule.
Above that, though.
You what?
How do you do the one above it, though?
Oh, I graphed these two functions on my calculator. I did derivative of that, I set them equal. I found the intersect point, that's it.
Wait, so you did both of the derivatives, and then you put that into your calculator?
Yep. No, in my calculator, I typed this in y1,
Okay.
this in y2. In y3, I typed the derivative of y1. Like I typed derivative y1 at x equals x. And then in this, I typed derivative of y2 x equals x.
Oh.
And then I turned these off, and I only had the derivative showing, and then I put it equal.
Is that really the right way?
Why not just do the derivative first?
Because I don't trust myself. But you could.
Oh.
But I don't trust myself to not mess up. And my calculator will do it for me. Okay, derivative, guys, product rule, you ready? Derivative of the first would be 2/3 x to the negative 1/3 times the second, plus the first x to the 2/3 times derivative of the second. Okay?
Right.
So let me rewrite it like this.
But that's gross. So, like, is there just no way to avoid that?
I'll show you a trick. You want to see a trick, kids?
That sounds very sketchy.
You want to see a magic trick? All right.
I'll refill it.
Okay. So, I'm trying to think how to explain this. All right, we're going to set this equal to 0. We want to find the zeros, okay? Now, you're not allowed to cross things off of, well, gosh, let me show you two ways to do this. You're not allowed to cross things off of both sides, but here's what you can do. I can take this with an x of 1/3 on the bottom, that, and I can move that to the other side. Okay? And then I could cross multiply. Now, if I multiply that by that, what do I get?
Oh, man.
6x. So when I have a 1/3 and a 2/3 like that, it's going to work out really nicely. And over here, I get 10 minus 4x. So I get 10x equals 10, x equals 1. Woo, crazy, right?
That's a sketch.
Yeah, I know. You guys hate that. Okay, I'll show you another way. You ready?
No, I liked it. I liked it.
I like
it.
I just don't like it.
Ooh. Here's another way. I want to factor out an x to the 1/3 on the bottom. This is actually a better way, okay? Check it out. Okay, so I'm left with 2/3 times 5 minus 2x minus. Now what happens when I factor out a 1 over x to the 1/3 from an x to the 2/3? You guys know? If I have an x to the 2/3 and I'm factoring out that, when we're factoring something out, we're dividing, right? And when I divide by a fraction, what am I really doing? Multiplying by the reciprocal, which just gives me x. That's crazy, right? And so we actually have 2 points that we have to worry about. If I were to set this equal to 0 and solve this inside part, I mean, look, multiply everything by 3 to get rid of this 3 right here. distribute that, so 10 minus 4x minus 6x is 0, so 10 minus 10x is 0, so x is 1, right? But the point is, on my sine line graph, I have a 1. Now, if I did it the first way, where I multiply things across, I'm like kind of losing a number. I also need to have 0 on my sine line graph, because that's where this ended up on the bottom. So sine line graphs can be tricky, because you have to have where the derivative equals 0 and where the derivative is undefined. Dun, dun, dun. Okay? And now I have to plug it in, which is like freaking gnarly, dude. I don't think I want to plug it into that one. I think I want to plug it into this one. Okay, let's plug in.
Negative 286.
Relax, bro.
That's on.
Let's plug in negative 1.
I'm
just
doing
thinking.
it right now, Zach.
Okay, if I plug in a negative 1, the cube root of negative 1 is a negative. If I plug in a negative 1 right there, that's 2/3 of 7 plus 2 is positive, so that's negative.
Two right.
Oh, good heavens. If I plug in a 1/2, that's positive. 10/30 minus 1. That's positive. And if I plug in like a 2, that's positive. 1. And that's negative, so it goes back to negative. Plugging in is a real pain in the butt on that one. So it's increasing on the interval 0 to 1. That was the worst thing I've ever done in my life. Okay.
Why did we put 1?
Why did I have a 1?
Yeah, why did we test 1 on the sine line graph?
No, I tested a half and I tested like 2.
No, I know, but why was 1?
Oh, because when I factored out the 1 over x to the 1/3, and I had this, and I set it equal to 0, I multiplied everything by 3, and I solved it, and I got down to x equals 1. Okay, now, guys, we did one like this last time, but I want to show it to you again because it's that important, okay? Definition of the derivative. The first time I taught this to you guys, I think everyone's like, oh my gosh, it's so crappy. F of x plus h minus f of x over h, right? It's obnoxious, it's annoying. Hopefully it makes sense now. Here's what I want to make sense to you. When you see this, I want you to think, ugh, crappy derivative. That's just a crappy definition of the derivative, right? Where we used to have to do like the points to get closer together and all that stuff.
It's certified null.
So when you guys see that, I want you to go, oh, I'm not really doing that. All I'm doing is taking a derivative. That's how easy this problem is, okay? So if I take the derivative of this, what do I get? 1. Derivative goes on, yeah, negative sign. That's my answer. That's it.
Seriously?
That's it. So easy. Okay? So you have to look at that limits thing and say, oh shoot, that actually just means derivative. You're not actually doing a limit on this problem. Does that make sense?
Wait, like we just need to do the derivative.
Hmm?
Why
Because-
did you put it on there?
Because it's on the AP test. Don't blame me. Alright, I'll see if I can find any more of those. I'm going to skip around a little bit to stuff I think you might find tricky before we move on to the next. Okay, this one. I know I should really number these, but... The main thing I want to know is if you guys can turn that into something I can actually take the derivative of. Now, this is x to the first and x to the 1/3. So together, what will that be?
4/3.
4/3, you guys get that? But it's on the bottom, so I need to bring it up. Negative 4/3, okay? Now, guys, now take the derivative of that. All right, can you guys take the derivative of that now?
I never made that one college. We have a giant wood killer thing.
What's the, okay, it's 1/2 x to the negative 1/2, and then plus 4/3 x to the what? What's the exponent on this one going to be? Very good. Nope. That's the distractor answer. That one. Right? Okay. Hi, Maddie. We reviewed today. Guys, we don't do this very much, so I'm going to go over it with you in the hopes that it'll maybe stick in case you have like one multiple choice question on this. If I asked you what do you think, except for Jacob, the normal equation is, any ideas, like even a guess? I'm thinking it's not parallel because then it would just be the equation of the tangent line or parallel. What do you think normal means? It's perpendicular. Yeah. So like if I have a curve like this, the equation of the tangent line here is like that. The equation of the normal line is like that. Okay? Crazy, right? So I can still go like this. Y minus y1 equals mx minus x1. And this is x1 and y1. Which, I have to plug in 1 to get that. So that's the point 1 comma negative 1.
No. Well,
Right? Okay. Now, can you guys take the derivative of that? Quotient rule, right? Okay, derivative would go derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. Up here, this is 2x minus 3 minus 2x, which cancels out. So it's negative 3 over 2x minus 3 squared. Okay? Now, plug in 1. What do you get? When I plug in 1, I get negative 3. So the tangent line has a slope of negative 3. The normal line has a slope of what?
1/3.
Positive 1/3, that's right.
Oh, positive 1/3?
Yeah, it makes it a negative reciprocal, yeah.
Got it.
Okay, so it goes like this. Jeez, this is annoying. So it goes like this. X minus 1, y minus negative 1, so plus 1, and then 1/3. Which equation is that? There has to be a 3 on the y, right? God, the worst part is changing it to standard form, I swear. Oh gosh, okay, let me multiply everything by 3. 3y plus 3 equals x minus 1. We bring that over. X minus 3y, and we bring that over equals 4. God, I hated that question. That was annoying. You guys okay? Okay, let me do a couple more. Let me look at this one. I like this question because it's actually just listing out what MVD is, mean value theorem. It's saying that there's a point somewhere between 1, 1 and 9, 3 where the tangent graph has the same slope. So I want you guys to find the derivative of this and set it equal to the slope between those 2 points and tell me what you get. Okay? So derivative equals slope is what we're looking for right here.
Derivative of slope.
Okay. My derivative of x squared is 1/2 x to the negative 1/2. My slope is y2 minus y1 over x2 minus x1, which is 1/4. Now, I actually rather would write this, x to the negative 1/2, as an x to the 1/2 on the bottom. Now, I can't tell you guys how many times my students will get to that point and then they're like, I don't know how to solve that. Do you? No, I'm just kidding. Do you guys know how to solve that?
Square root.
Square root both sides?
No, that is a square root.
Yeah, that's a square root, but how do I solve it?
I'll tell you the second.
Pull it up. You can think about it.
I mean, yes, you can think about it, but fine. Right.
Wait, you can cross multiply, right?
Cross multiply is what I would do, or since they're both over 1, you can just set those equal or whatever. Yeah, for sure. So 2 squared x equals 4, divided by 2, x is 4. So it's got to be that one. Okay? Next page. Oof, you guys, let's go. Skip this question, it's easy. Do this question right here.
This is an easy question.
You guys got this. You got this.
It's this, right? No, it's
No,
not.
Megan!
You lied to me. Wait, this is like unit
Unbelievable,
1.
Megan. Literally get your
This is
crap
unit
together.
This is literally what we did over the summer. You think I
Jack
remember
here?
this?
Megan, you're wrong.
I saw Ivory.
Ivory had to leave, but she was
This is like unit 1,
Okay.
right?
Yeah.
We did this in the summer.
No fun in this
There's no way I
here.
remember this.
Megan said
Take,
C.
find,
Aiden,
I don't know.
what's up, my guy?
I don't know.
Nathan today? Sadie?
Predict the derivative.
Yes, here, let's go. Sophie's here, let's go.
Unit 1 or unit 1? Why are you
Cohen's not here.
It's not.
Chris is here. Chris, you be able to stay for the rest? Alright then, you're chilling, man.
He's bringing on.
Weston's here, Ryan is here.
Or maybe the unit. We're in unit.
I saw Ellie. Did I see Ellie? Yeah, oh hi Ellie. Nice. Okay. We'll do more in a minute. Guys, remember when you see this, what are you supposed to think in your head? Oh, geez, crappy derivative, but it just means derivative. Derivative of what? Cosine. That's right. So, that's it. Derivative of cosine is negative sine. That's it. Seriously, I'm telling you, these limit questions are easy.
How am I gonna remember to
Now,
more stuff to remember?
could you do this one a different way?
Yeah.
What way? You could do L'Hopital. I mean, it's lame, but you could, I guess. Here it goes. So it'll be negative sine. And then the derivative of cosine is...
Wait. How are you going to do L'Hopital?
No, you can't do L'Hopitals. I lied. Nope. Definition derivative. That's the only way to do it. Just kidding. Okay, we're going to skip that question. We're going to do this question because, let's be honest, I put a couple of these on the test and you guys freaking tank them every single time.
No, no, I got these ones.
Is this a
Really?
Yeah.
Yes. Okay. Guys, all it is it wants it to be continuous and differentiable. Now, when it says continuous, what that means is when I plug in 1 here for x, and when I plug in 1 here, they should be equal. Okay? You get, that make sense? So, 1 plus 3b plus 2 times 1 squared. So 1 plus 3b plus 2, or can I just call that 3b plus 2? Yeah? And that has to equal 1.
Wait, where did the 1 go?
I don't know. 3b plus 3, I'm so tired. I just want a day off. Right? No, Saturday I had to do ACT and then I had to tutor for a bunch of hours. Oh, Sunday, it's the board rests on Sunday. You should rest on Sunday, Ms. Mitchell. No, I would be here writing stupid decorating. All right, anyways. It's fine. I'm fine.
You should have made it, then do it. Like during.
Guys, look. Right now, look, I could combine the B's, yeah? But other than that, shoot, this is not giving me enough information.
Well, now you can plug in.
But now, what does differentiable mean? Why is that not differentiable, but like that is?
Sharp point.
Okay? And it's because the derivatives have to be equal. So if this derivative is 2 and this is 2, it's got to equal. Like this, the derivative on this side could be like positive 5 and this side's negative 5. It's not equal.
That doesn't make sense.
What do you mean?
Wait, sorry, what did I do?
Oh, okay. I thought you got like this a lot. Make sense, Jacob. So if it's differentiable, that means I find the derivatives, right? Guys, what's the derivative of 3bx? 3b. What's the derivative of 2x squared?
4x.
4x. What's the derivative of mx plus b? M. And I'm supposed to plug in 1 to the top and to this one, right? But I'm plugging in 1 for x. So this tells me 3b plus 4 equals m. Do you know what that is? Do you know what that is, boys and girls? It's a system of equations. It's 2 equations with 2 variables. Have we talked about this enough now that you guys can solve those? Yeah?
Okay, so I got 3b plus 3 equals m plus b, right? Which is what you got.
Yep.
But then I also got 3b plus 4 is m plus b.
No, because the derivative of b is 0. Because you gotta take the derivative.
Oh, that just made my day.
Jacob got something wrong, everyone gets 100 points. Yeah. Okay, so differentiable, in the same way that continuous means the functions are equal, differentiable means the derivatives are equal. Okay?
Second one for what?
Okay, so m equals 2 things, right?
Oh, yes.
Well, if m is this and m is this, can I substitute that in there and I can have 3b plus 4 equals 2b plus 3?
Derivative right there.
And solve that?
I get that.
So you said the derivative.
So b plus 4 is 3, so b is negative 1. And then how do I figure out what m is once I have b?
Otherwise, yes.
To either equation, so let's plug in here. So negative 2 plus 3 is m, so m is positive 1, b is negative 1. Systems of equations, y'all. Okay? No, you can't zone out. I plugged a 1 into the top, a 1 into the bottom instead of equal.
Oh, okay.
And then I plugged 1 into the derivative instead of equal. Okay, this is a really good question. Did you guys see if you could solve this one? Steven, you can come in if you're going to do calculus, but your little friends cannot.
We just want to sign this kid up for the math test.
Oh, he can take it.
Which kid?
For the state. Is that Wednesday?
This Wednesday? Yeah.
All right.
What time?
Well, I got you. I got you for state math. I got you. Steven, Garrett, you're not a fan? Stay that way. Guys, do this question. No. Gabe? Well, I saw your Gabe's curly hair. Gabe here? No. Hi, Mitchell. Hi. Annabelle's here. Pat's here. Wyatt here. Bro, I'm gonna be here until like 9:30.
You win.
Don't complain to me.
Mitchell, but when did I will too. But when did you get here?
7:40.
I win.
Okay, fair.
I got here at 6:15.
Lydia. Henry is here.
As it's approaching. It's me, Annabelle.
Anna's here.
Henry is so much nicer.
Okay. Guys, this is a pretty easy limit statement to understand. The limit as x approaches 1 means as I'm approaching 1, both sides have to meet up. As I'm approaching 1, both sides have to meet up. And where do they meet up at?
-2.
So that's false.
Wait, so when is it -1? When is like the
F of 1 is -1. So the point is -1, the limit is -2. Because remember, the limit is you driving along the roads. Where are you going to get, right? This is Aiden, this is me, we're meeting up at a diner. Oh my gosh, the diner moved. It moved over here. So we can't hang out, but me and Aiden are still
That's
over
where the diner
there.
actually is, but that's not where you were headed.
Exactly. So it's where we end up. I would go to a diner with Aiden. He's a cool kid. Alright. That's what's up. Guys, okay, I think, let's go back to 2 in a minute, because that one's harder. Okay, let's look at this one. Okay, -1 from the right. So where is it approaching -1 from the right? What is that approaching? 1. What's f of -3? What's the point at -3? 1. That's definitely true.
2 is true.
So 1 is definitely not true.
It doesn't matter if 2 is true.
And now, by process of elimination, I would definitely pick that, but we need to talk about that. What?
Yeah, how do you know?
Okay, I'm going to talk about it. Annabelle, what's that?
What it's saying is that the derivative
Oh.
at 2
Oh.
So don't touch that. So from the right.
From the right, it's traveling up to 1. And what's the point at -3? 1. Ryan, I swear, if you keep messing people up, man.
Ryan Lewis is literally stupid.
Oh my gosh, why are you so dumb, Ryan?
It was good thinking.
That's fair. I like your thinking. Okay, guys, look at this middle one. Yucky, 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 yucky. What does that mean? Are we like getting that now? That crappy stuff means derivative, and it specifically means the derivative at x equals 2. Not because of that, but because it's a 2, because you have f of x plus h minus f of x over h, derivative at 2. That statement that I just circled right there means the same thing as f prime of 2. Cool? Yeah, let's go. What is the derivative at 2? It looks like he's going up 2 over 1, right? So is the derivative at 2 2? Yes. Okay? I like that one. That's a calculator question. I'm not going to do that one again. We're good.
Wait, what one's the calculator question?
This one?
Oh, okay, so that was really
Really?
No, that's probably not a calculator question. Let's do
Dang
it.
it, that was really struggling.
Know your
Okay.
sign, know your... Oh, wait.
All right, that's fair. That's fair. Where does e to the anything equal 0?
Never.
Oh, we have to take the derivative though. Gosh darn it, guys. Okay, there we go. There's my derivative. Now, as we just discussed, e to the sine never equals 0. How many times does cosine equal 0?
On the interval?
On the interval 0 to 2 pi.
Twice.
Now, hang on.
I'm or
Yes, twice. Pi over 2, 3 pi over 2. Right?
yeah.
2 times. Love it. Okay.
Exactly.
Okay, you guys ready? This is the graph of G. This is the graph of F. H is F times G. Find H prime of 3. What rule do you have to use on that?
Product rule.
Product rule, and you have to be able to find H of 3. You have to be able to find F of 3 and G of 3 and F prime and G prime. You can do it. I believe in you. Let's try it.
The function's the one under the graph.
Yeah, I'm skipping around a little bit. Brian's not here. She was
We worked
not that Ryan. Ryan Bishop. Draper. Draper, you are here. Why are you sitting over there? Ben is here. I thought Garrett would come in, right?
Yeah, Sarah's here.
What's up, Garrett? Landon's here. Tavish? Ah, no. Ray? No. Dang it. Ferrari's here.
Oh, that's right.
Jacob and Megan are here.
There we are.
Yeah, you are. Abby Stone. Oh, there you are. You're so quiet. Gotta work on that. Carolyn's here. Isaac is not here.
Isaac was here.
Maddie? No, Maddie didn't stay. Ethan? No. Okay. Great. I think I got it ready. Guys,
Oh, you're actually right.
h of x, what's the derivative? Derivative of the first times the second plus first derivative of the second. Right?
Yes.
Okay. Now we have to do all of these at 3. Okay. F of 3, you guys agree with me? F of 3 is 1. Regular F. Regular F. What's F prime of 3?
I think mine was better.
Very good. Negative 1/3, yeah? Because it's down 1/3. Okay, great. Okay. Regular G of 3 is 3. And what's G prime? Of 1/1. Ew, what? This is so easy. So it's negative 1 plus 1, so it's 0. Did you guys get 0? I like it.
Mitchell, I made an equation for h of x and then derived it and then plugged in 3, but I got 0.
What?
And it worked.
You did like 4 times as much as work as anyone
No,
else.
but
Yeah, you did. Wait. Let's just all appreciate. So you wrote an equation for this side of the piecewise function, which y is negative 1/3 x plus 2, and you wrote y equals x, and so the multiply of both of those is negative 1/3 x squared plus 2x, and then you derivative that. Brilliant, I love it.
That's so cool.
It's so extra. Okay. Okay. Calculator question. See if you guys are awesome enough to do this by yourself. Let's go. Let's get it. Calculator question. Ah! What is wrong with you people? For real. E to the 3x, 6x squared. So guys, are you going to take the derivative of e to the 3x plus 6x squared plus 1?
no.
You better not. I mean, you can. It's not that hard, but come on. Let's use the tools at our disposal. Okay? So it's e to the 3x plus 6x squared plus 1. Now, we do have to come down and turn this one off because I didn't put anything in my y2. So if you're doing it that way, go turn that one off. Go turn that one off. Whoa. Oh, by the way, does anybody know what horizontal tangent means? Derivative equals 0, right?
Oh, that does indeed.
So let's calculate the 0. To be left, right, enter. Okay, negative 0.156. Yeah, I want to say this. Okay, there's actually one other way to tell where the derivative is 0 without actually graphing the derivative. Not exactly. Guys,
Oh wait, you couldn't have done that.
where on that graph is the derivative 0? That's the graph of the regular function. Yep, horizontal tangent. How can I find that on my graphing calculator? I can calculate a minimum. So calculating the minimum of the regular function is just as good as calculating the 0 of the derivative. Okay? So there was a couple of different ways to do that. Alright? Calculating a relative max or min of the original is the same as calculating a 0 of the derivative. Cool? What was it? 156? Okay, I think we're going to go move to the next packet. Let me just look at this real quick. if there's anything crazy. Oh, this is a good one. This is a good one. This is a good one.
It's just
Only the true masters will get this.
Ryan, that was like a little embarrassing, but like,
I missed
put it out there.
I missed my last name.
If you get this, I'm gonna say
These are something.
nope.
There you go.
Well, maybe.
I
I
don't
don't
think
know.
you can say dubs anymore. You lost.
One.
I said dubs.
Wow, we got lots of choices. It's either -1, 0, 1, or 3. Okay, let's talk about it. What does this mean?
Derivative.
The derivative of what function is it talking about?
X.
At what point?
3.
Okay, now, we don't have a derivative of the absolute value, although we can do it separately on two separate sides, but we do know what the absolute value looks like. What does it look like? So what is the derivative at 3?
Probably 1.
Straight up genius, Aiden. You absolutely got it. Do you guys remember what the derivative graph looked like?
Oh yeah, I do remember.
So the real graph.
Wasn't it like that?
Oh wait, because it's times.
You know? Yeah, that was a cool one. Okay.
Wait, then why is it 1?
Oh my gosh, stop it. Because I wrote it upside down.
That's crazy. That was on an AP test. What do you guys think about that one?
This is 3, this is 1.
Why is it 1?
A derivative, a function whose derivative is a constant multiple of itself. Do you guys know what those words mean? Okay, tell me what words you know. Okay, but tell me what words of those you know. Yeah, you do. What does linear mean? The line. And is the derivative of a line a constant multiple of itself? No, it's the derivative of the line is 0. Okay?
Line is 3x.
Do you know what a quadratic is? What is
3
it?
times nothing is
Is the derivative of that a constant multiple of itself? Derivative is a line.
Like, look,
What does it mean by
You'll see.
multiple of itself?
Periodic. You'll see. What is periodic?
does it again.
Sine, cosine are periodics. Are their derivatives multiples of themselves? Not exactly.
This is a constant.
Logarithmic is like ln. What's the derivative of ln? It's not a multiple of itself. But, my friend,
Wait, Alan is.
what's the derivative of e to the 5x? Is that a constant multiple of itself? What's the derivative of that? Is that a constant multiple of itself? Cool, right? Just easy. Okay. Okay, real quick, I keep finding good ones that I want to go over. Real quick, look at this one. Okay, again, now this is an alternate definition of the derivative form. Instead of going f of x plus h minus fx over h, it goes f of x minus f of a over x minus a, but it's still the same exact thing. It still means derivative, okay? So I want you guys to change that to something that doesn't look like an ugly limit. So what would we say? That means derivative of f at a equals 0. Which of those says that?
F prime of a equals 0.
Derivative of f at a equals 0. You see how there's like so many of these over and over and over again? And you just keep getting them if you know that that means derivative. Okay?
Questioning you based on your knowledge.
You just
How it goes
assume that
principles.
they. Wait, man, I have a question.
Whoa.
Do you know when to use the derivative definition and when to use like
Okay. Derivative definition will specifically say either h approaches 0 or x approaches a. Everything else will be like limit as x approaches 4 or something like that. But h approaches 0 or x approaches a, is coming now. That's easy. Okay, I think I'm going to call it good because this section just goes on for freaking ever. Wait, let's just do one more.
That's a good thing. That means there's lots of derivative questions on the test.
I have a question.
Yeah.
That one, there were no parentheses. Would you be toast and you have no clue what the answer is, or is it the exact same thing? Like if you distributed the two, but took out the.
Oh, no, you can still figure it out. You have to factor it out.
No, like you have tangent of 2x plus h.
Oh, then no. Got it. So guys, it's the same. Find the derivative of tangent 2x. It's all the same. And what's the derivative of tangent 2x? Secant squared 2x times 2. Boom. See how easy? Okay. Let's go to packet 3. Let's go to packet 3. You guys need a stretchy break now. We're fine, right? 3 minute stretchy break. 3 minute stretchy break.
Mitchell, you should mark me as here. Because I am here.
I did mark you as here.
Alright, because I'm kind of leaving. Oh, it's the awards Bye, Jacob. My favorite. Hard work. American reading.
Pretty sure they think they'll be messing with you. You know what? This will probably make me better. The fact that I have to work hard for it. Okay, so I'm gonna use this for the better.
I just want to spit it in. Actually, give me a
You actually have to make a circle. There you go.
I haven't been spitting this whole time.
If she stops, it's gonna hurt.
Guys, just stop. Oh, maybe people do think I would see her if I did this right now. Otherwise, don't feel like it's like I'm sorry if that was
The chair escaped.
Oh, I did. You're supposed to let it go.
I wanted to have it. That's a little. Leaning back is leaning forward.
Is it kicking in?
It's like, you see what this is what I did. I don't care. So you're like, okay, hustle my hands.
You know, like last year, I don't
You're like, nope, just kidding.
I can't remember if it's still even if I show how to do it, and you guys really
What the heck? I didn't restart by itself.
And it's 18 seconds left.
Oh, I should go sit down. It's almost like you don't want to learn calculus, guys.
Why would someone think
Why would you think that?
I still kind of
You guys want to see something funny? Hold on.
I have a question.
You guys went through 90 fruit snacks in 2 sessions, correct? Yeah, buddy. Yeah. Oh, what should you get for yourself? Soda delicious. I don't know. Do you want energy drink? It's a little late at night. I don't know. I always stick with
there's a new Percy Jackson?
always good. Common sense. I guess like cherry, and I like that.
Are you FaceTiming someone? What is this? FaceTime on what happened starting after Heroes of
Yeah. We got our costumes for the assembly for Witch Week. That's me. That's me and the kid.
I didn't.
Okay.
I think I made Isaac. Sorry. I realized that was Jack. Because we were thinking about all the standing telephones. I did. I didn't.
Let's go. Let's see how many we can get done. We got 45 minutes. We're gonna speed run this. You guys want to speed run?
No. Yes.
I love it. Oh, that means you can't say, "Oh, I looked down for a minute." You have to focus. 45 minutes ready. 45. Great. There we go.
I need more cookies.
Hey guys, what if you don't know what a one-to-one differentiable function is? Skip this question? No, at least try to do it anyway, because look. G prime when it gives me this other stuff. And look at this, oh my gosh, look at that word right there. What word is that? Inverse. Do you guys remember how to do this? Remember it goes like this. 1 over f prime of something. Right?
I like that thing.
Yeah, I like these too. And then off on the side we go, g of 5 equals something, which means f of something equals 5. So what's the something? And then I go, look, oh, f of 4 equals 5. So g of 5 equals 4, so that's my magic point. But then the answer is 1 over f prime of 4. So it's 1 over 2/3. So it's, let's go. Yep. Amazing. Easy it does. Okay. Okay, next one. Yeah. Guys, next one, implicit. Do you guys remember how to do implicit differentiation dy dx?
Yes. I love that.
We're speed running this. Alright. Just kidding. Okay? Product rule. Yeah? Derivative of the first second plus first derivative of the second. So that's product rule. The derivative of x squared is 2x. The derivative of 6 is 0. Ooh, tricky. Okay, not really. Let's solve for dy dx, yeah? You guys remember that when we're solving for dy dx, anything with a dy dx stays on one side, everything else goes on the other side. So negative y, negative 2x. And then how do I get dy dx by itself? Divide by x. So that's going to go in here. Okay, love it. Now, it tells me to plug in x is negative 1. That's an easy dubs. Here's the problem. Well, you guys tell me what the problem is. What's y? We don't know why.
I don't know why either.
Can we find it? I'm sure I could you? Yeah, you can. If x is -1, then negative y plus 1 is 6. So negative y is 5, so y is -5. Yeah?
No, go back. Just hold there. Hold up.
Okay.
Hold up.
You
Explain.
guys don't like my speed run. Alright, if x is -1, let's go into here, right? -1 times y is -y. Yeah?
Yes.
-1 squared is 1 equals 6. Just back to the original problem. Subtract that over.
Okay.
So it's 5, so y is -5. Now that I have that, I can go back to this dy dx. Oh, so many negatives. I hate
Wait,
it.
let me get there. Okay.
-5 is 5. -2 and -1 is +2 over -1. So I get
So that's just them both being
-7. Let's go. Ooh, calc question, and you guys, this is so good and so freaking important. Super, super important, but you guys can do this. Follow the formula, okay? And it says inverse. Now, we can't graph the inverse of that on our calculator. This is what we do. G prime of 2 is 1 over f prime of something. You with me so far? What do we write on the side?
F2.
G of 2 equals blank, which means f of blank equals 2. Okay? Can we put that into our calculator and see when it equals 2?
Yes.
Let's do it! So if we put this equation into y1 in our calculator, and then we put 2 in y2, I'm not going to put it up, you guys can do it, right? And then we do the intersect, right? Actually, I'm going to put this up. I need to show you guys calculator stuff. Because I think one of the things my student last year felt like we didn't do enough calculator stuff, and this calculator stuff felt like so good. Okay.
I'm barely started. Good job.
Okay, so I went 2x plus sine x, and the line y equals 2, and I'll just hit a zoom 6 to reset everything.
It took a while for me to figure out.
And then I'm going to calculate that intersect point.
Because I told you.
Because she told me.
So go over there and
While
just
you were
hit
out, I
1,
was
2,
just like,
3
oh,
times.
she's coming back, I can do stuff.
My intersection is 0.684. Is that my answer?
No.
Heck no. All right.
It's derivative.
What that number is this number. Which means that that's this number. Which means it's that also that number. So I need to do 1 over f prime of that. You guys want to see how fancy I am?
Yes.
Check this out. Okay? Go to your home screen. Go.
I
Alpha
got
fraction.
to see, completely forgot the next line.
1 over f prime of that. So the derivative of y1 at 0. What was it, 684?
I want to do the whole calculation.
That's just if you want to be like so super fancy and do it all in one step. If you want to do it in 2 steps, that's fine. But I did then 1 over that. That's dope, right? Do you guys feel like you're getting used to where all the math buttons are now? The calculator buttons, alpha trace, alpha y equals, all that stuff? Roll and practice it. What do you get, okay? That was dope. I love that. Okay? All right, cool. Next. Slope of the tangent to the curve. What does that mean?
Tangent line?
Yeah, and what's specifically the slope of the tangent line? Derivative. just saying find the derivative at 1. Okay? This looks like another, oh my gosh, this next question looks fun. Okay, this looks like another implicit. You guys want to do an implicit right here?
This is so long.
So it's a little bit of a pain to find x, but I believe in us. We can do it.
What in the world is
Derivative for a second. Derivative second. Oof, that's annoying. Okay, that's super annoying. Okay, everything that does not have a dy dx, move it to the other side, which is just this little sad lonely y. Right? Minus y. And then everything else, if I factor out a dy dx to all this, which is x minus 2 plus 8y, and then what do I do to solve for dy dx? Divide that over. Okay? Alright, so no, like showing all my work, but are you guys chilling? You guys with me? Now, y is 1, but what do I have to figure out? I gotta figure out what x is. And if y is 1, then x minus 2 plus 4 equals 6. So x plus 2 is 6, x is 4. Right? So if y is 1, x is 4. So I get negative 1 over 4 minus 2 plus 8, which is negative 1 over 10.
Yeah.
Let's go. I always get a little excited when I get the answer and it's on there. I feel like I didn't make a mistake. This next one is super cool. Just by looking, what do you guys think the answer is? B. Anybody else?
It's C. It's C. It's an exclamation mark. It's the
Speak up then. All right.
We were just perfectly in sync. No, Mitchell, I kind of think it's B.
You think? Okay. What's the first derivative of e to the kx? E to the kx times k. And then it's k e to the kx times another k, which is squared. And then it's k squared e to the kx times another k, which is k to the third. Do you guys know what this means?
Factorial.
Factorial? Yeah, it means it's 5 times 4 times 3 times 2 times 1.
It means
Which
it's
is not what it
excited.
says. It does mean it is.
Where'd the 5 come from? Wait.
Because it's a fifth derivative. But we multiply by k 5 times. Okay, good one. Love it. Oh my gosh. Okay.
Why are they capitalizing the arc? Special type.
Out of the 30 people in here, how many do you think remember the derivative of arc sine?
Give me 1 second. Give me 1 second. It's the
Wait.
Maybe 4.
Without looking,
What do you mean? Give me 1 second.
just arc sine for now. What's the derivative of arc sine?
Take it back.
It's
1 minus x. Ha, that's great.
I have my derivative. Thank you for
Yeah,
your
1 minus x squared. Okay? Now, guys, is it to be real right now?
It's time to be real. Oh my god, I'll be
I do.
Wait, what was I gonna say? Did he make you lunch?
Together or oh, we'll be together.
Cause
Okay, hi everybody. Hi.
There are times where you're like, I can make pasta, and then you're like, phone's all in and back. Ask her to, do you have pasta? Did you make pasta? She goes, no.
That was horrifying.
Nope.
Jacob, what do you mean you don't like it?
Because there were 4 different. Every day after the instruction.
That's fun. All right.
That was not.
Guys, just from that, can you tell what the answer is going to be? What's the answer going to be? Yeah. So, arc sine is 1 over square root of 1 minus x squared. Arc cosine, the derivative is the same thing with a negative. Arc tan is 1 over 1 plus x squared, no square root. Okay, that's fun. Ooh, the next two are easy dubs. These are, what are these called? Chain rule questions. Okay, do the next two. Do those by hand. Do those by hand to see what you get.
Two art cooks. The fact that I would. Think of this. Each of 2, so you just plug in 2. 2 squared is 4, minus 4 is 0. Everything just goes to 0. It's like so. Jacob.
The chain rule, you don't even need it.
Wait a second.
If you forget chain rule, you still get this one right.
Which one? This one?
Yeah.
For real?
Yeah.
Oh, that's annoying.
If you forget everything.
Because 2 squared is 4. You get 4 minus 4.
Oh, that's dumb.
Wait, what? But you have 0 to the negative something. And you have 1 over 0.
Oh, hold
That's
on.
awful.
Hold on, Zachary.
I'm not scraped up.
Because it's 3/4 x squared minus 4 and 4th root on the bottom.
What?
So it's actually 6 times 2 over 0.
What?
Oh, what the hell?
What did you just do?
You're right.
You lost me.
No, I believed you, so that's an L for me too.
Wait, what? Explain that.
I'm about to. What was it? X squared minus 4.
Well, no, I have it over it, and then she said
It was 1, but.
What did it tell me to do? The derivative at 2? Yeah, that's the problem. It's not differentiable at 2. Because it's at an endpoint, huh? Tricky. Alright, that was a tricky one. Okay, this one's like easy dubs though, right? 2 cosine. 2 cosine?
I don't understand.
So that's negative 4. Okay. So when I go to plug it in right here, you think, oh, it's 0 to the negative 1/4, so it's 0, right? But 0 to the negative 1/4 actually means 0 to the 1/4 on the bottom. And so I'm dividing by the 0, so it doesn't get okay? Yeah. So that's why I like to rewrite. Like I would probably rewrite it first, and then I could probably see it better. I don't know.
She tricked me too.
Okay. Calculator question.
okay.
You guys want to practice this? We got a bunch of calculators, but let's just practice it. Okay. Are you going to take the derivative by hand? Heck no, I'm not. What if I don't remember what arctan derivative is, you know? I'm not gonna do that.
Guys, I take it back. Okay.
Okay? So, let's do some calculator stuff. Hey, swivel. Boom. Yo. All right. Are you guys typing? Why do I not hear you typing away on your calculators? Typing, children. All right.
I don't really want to
What's the first one say? 1 over x squared? 1 over x squared. Hey, you guys know where the arctan button is on your calculator? Second tan. Now, I don't care about those. I care about the derivatives of those. So then I'm going to go math 8, d dx, y1, which is alpha trace, y1, and then I put x equals x, and I'll graph the whole
What the
thing.
freak? What the heck is this?
What?
Hey, Brenda. Hey, it's so vagina.
And I go math 8,
It sounds like she's like dying. Also,
and I
this
go
is
y2,
Brendan.
which is alpha trace y2.
This is Brendan Larson. Hey, I've got
Gosh
not.
dang
Hey,
it. Keep
Brenda.
him in the wrong place.
I'll have you know. This dyslexic.
X equals x.
And then hey, but then I was
Okay, I don't want it too garbled up, so I don't need to see my original function, so I'm going to turn those off by just pushing enter on the equal sign.
there, please, there, that. And then you go.
Whoa.
I don't care if I but I can call him.
Hey guys, I cannot see what I want to see on here. Do you have any recommendations of how I can zoom this in?
No.
Hey, let me do zoom box. That's
What I
fine.
called you. I think a little bit stupid.
Guys, watch what you do in zoom box. You just go enter.
He thinks he's smarter than me.
I am.
No, you're not.
Everything.
No, it's so false.
Lydia, you're losing it.
What, me?
Focus, buddy.
I'm so focused right now. Is Ryan smarter than me?
Wait, Mitchell, you should answer that question because now I want to know.
What happened?
Is Ryan smarter than me? Please, it's not
She
him.
doesn't want to hurt you.
Hey, I got an intersection line, negative 2.359.
Even if you're better at math than me, I know without a doubt that I'm.
Is Ryan smarter than who?
Yeah, I think I'm actually better at
That was me.
Wait, did he say yes?
Yeah.
But not in English.
But not in English. She doesn't know me.
This isn't English.
I don't know you outside of this room.
I'm smarter in every. No, except my dad is smart. Not
Yeah,
Ryan is smart. That is genius. That's right.
Negative 2.359?
Ryan has a better grade than me, man.
Let's go.
Yours is at 0.
I just got the. I know it all worked out. But none of it happened. Without my dad, where would you mind for that?
Guys, this is the weirdest thing I've ever seen. Let's take a look. If I plug in 0 right here, is this a continuous function?
Yes.
Yes. So discontinuous is false. It's continuous, that's fine. Okay, now for the next two, I'm going to have to take a derivative. Derivative of the square
You
root.
don't have to take a derivative.
Why? Well, I wanted to take a derivative.
You can see.
Because I'm going to take a derivative. Square root. X, 2 cancel out. Hey, f prime of 0 is a horizontal tangent, so it has to be 2 only. Look at that. All right, fine. Be that way.
Before we talk to her, because everyone's like talking about her. Looks like
Ricky. All right, guys, I'm ready for this. You guys ready for this? Okay. H of x is f of g of x. Guys, as soon as you see f of g of x, I'm automatically thinking chain rule. Okay? I'm automatically thinking chain rule. Now, blah, 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 blah. Okay, listen real quick. Here's the question. Horizontal tangent lines, I want to know how many h has. Now, go back to your definitions. What's the definition of a horizontal tangent line? Derivative equals 0. What's the derivative of h from up here? Come on, guys, please get this right. Lydia and Ryan, whoever gets this right is smarter. Lydia, you also have to fail to perform under pressure. The derivative of f of g of x. I want to find h prime, so I want the derivative of f of g of x. No, you can talk to each other. Yeah, you can have that by your side, because Ryan doesn't need it. Come on, Ryan, don't let me down. All right.
Yeah.
Did Ryan get Jacob on his side?
No, that's not cheating.
It's 75.
What?
It's 75.
That's not even
The 2 times I guessed that in class, he was right. It was right.
75? No.
There is no.
All right. Ryan, what do you got?
I guess.
Well, I'm not saying the answer. All I'm saying is, what is the derivative of f of g of x? It's chain rule.
No, it should be you there, Ryan.
Don't tell me the whole answer. Just tell me what the derivative of that is. I was mistaken, everybody. Lydia's smarter. Good job, Lydia. Ryan, hate to see that happen. You're a nice guy, but too bad. Okay. Guys, when you see a function composition, one inside of another, we go derivative the outside, leave the inside the same, times derivative the inside. Got it?
Oh, that's what you were asking?
Yep. Now, this will equal 0. This is such a cool question, you guys. This is we're going to call these 5 questions. Because the only people that get this right are the people that are getting 5s. Anyways, right?
That's me.
That's everybody in here if you work your butts off.
We guess and we get it right.
Okay, so it's where either f prime of g of x is 0 or g prime is 0. So can you guys tell me first where g prime will be 0?
Negative 3. It tells you.
Negative
Yeah, it's at the top.
1 and 2. Yeah, it does tell you that. And where would f prime of g of x be 0? Okay. F prime is 0 at negative 2 and 1, right? But then I'm looking for where does g of x equal negative 2 or 1? Because if g equals negative 2 or g equals 1, then it works. Where does g equal negative 2? How many times? How many times does g equal negative 2?
Twice.
I think twice. Okay, so that'll give me 2 answers. How many times does g equal 1? Twice. So 1, 2, 3, 4, 5, 6, 7.
No, but the very first one where it equals negative 2 probably doesn't count.
Oh,
Because
let me
it's
look.
the very edge of the graph. You're just being mean.
Yeah. It's gotta be 6, because there's no 7.
Well, there's definitely 3 places where the derivative, okay, so there's definitely 3. 1, 2, 3. And then it's there, it's wherever g is negative 2 and wherever g is 1. Because then f prime of negative 2 and f prime of 1.
Yeah, but this is a question of us.
Mitchell, but it can't be it can't be at negative 4 because we're taking the derivative, and you can't have the derivative of something at n
At an endpoint, so we're thinking there's 1 right there, and 1 there, and 1
But
there.
also we'll have 2 zeros. 0 would happen twice. So do we only count it 1 time?
What, 0 would happen twice?
Well, because 0 when g prime of x equals 0 is at 0, and also when g prime of x equals 1 is at 0.
Okay. I have thought my thoughts and I'm ready. I think we actually have to listen to that. Okay. So this first one was when x is negative 3, 1, and 2.
Negative 3 is 0. Isn't it 0, not 1? Yeah. Isn't it negative 3 0? 1 is the whiteboard of it.
Yeah.
Oh, that's fine. Sorry about that.
And then we have.
Okay. But then over here, f prime is 0 at negative 2 and 1. And g is negative 2 at, when x is negative 2, x is negative 4. Hang on, I got it, Jacob. I think we can use that when x is negative 4. Because then look, g equals 1 when x is 0.
We already used 0.
And when x is like 3 point something, like 3.2, but we use 0 twice. That's why. So there's actually only 6 distinct solutions, right? Because we use 0 on both of those. 1, 2, 3, 4, 5, 6. I hated that. I don't know about you guys. Yeah. 1, 2, 3, 4, 5, 6. It's just that I got 7, but it's because x equals 0 counted twice. It counted there and there.
I
And it's
still
only
don't get
once.
what you can use. If you have a function that goes like this, and it is 0 to 0 here, but it ends right there, I don't think it counts as a 0.
Because, right, but see, if as long as this is closed on the interval, what's g of negative 4? Is negative 2. And then what's f of negative 2?
Oh.
So it's an endpoint with g, but it's a derivative on f.
Okay.
I think we're okay. I want to skip through to some interesting ones. Actually, this is an interesting one. Let's do this one.
It's negative tangent.
Is it negative tangent? Okay, let's take a derivative with respect to x. Guys, what's the derivative of cosine? Negative sine. What's the derivative of e to the y?
Just take ln of both sides. Maybe 4. That's so much easier.
From the beginning?
Yeah.
Yeah, you're right. Yeah, because if I take the ln of both sides right now, it'll work, but it's annoying. You're right. ln of both sides gets rid of that. So y dy dx equals the ln of negative sine. And then if I divide by y, ln of both sides is divided by ln cosine. I didn't like that. That was messy. Let's do it a different way. Hey guys, let's do this a different way. Start by ln both sides. Oh yeah. Oh yeah. And now the derivative is the derivative of the ln of cosine, which is 1 over cosine times derivative of cosine, which is sine. It's actually positive tangent.
Wait, no, because the derivative of cosine is negative sine.
I know, it's actually negative tangent.
Really?
Wait, hold on.
Watch me have a breakdown in front of your very own eyes. Okay. That's easy, Dub. That's not bad. That's not bad. That's, real quick, which one of these is arctan of 3x?
A.
I skipped to the next page. Which one is the derivative of arctan 3x?
A.
B, chain rule, Jacob. Everybody gets 10 more points, Jacob.
Also, I got it right before Jacob did, so I should get extra points.
Wow, you get 1,000 points.
I wasn't arguing with Jacob. I was like, no, it's B. And he was like, no, it's A.
Unfreaking believable, this kid.
I'm like embarrassed to call you my brother.
I don't want to die.
Use the inverse chain rule to try to grow up front of her ass.
Jacob, you should like the
Hey, this looks crazy. You guys want to do this? Go to the one that says graph of the function g. Because you really have to go back to like the math facts on this one, kind of.
Oh, never mind.
You just got to go back to if you know your chain rule derivatives. This is crazy because it's g of g, but I love it. So, f prime of x. Because it wants to know what f prime of 1 is. So I have to derivative this. But it's g of something. It's an outside inside. Yes, it is right. You're redeeming yourself in my eyes slightly.
If you don't enter anything, you get what is it? 40 out of 100.
Okay. At 1.
40 out of 100 if you don't answer anything. And 40 is the average.
Okay, g of 1. It's not a race. Just kidding. It's always a race. G prime of 1. So g prime of 4 times negative 1. So the derivative at 4 up to over 3. Did you get D? Is that great, D?
Yeah.
Let's go!
Good job, Aubrey.
That's not.
I win
All right.
because I was.
Did you guys understand all that or like not at all?
I don't know. I just
Okay, so step 1.
good enough.
I said to take the derivative, it's a chain rule. So I do derivative of the outside, keep the inside the same, right? Times the inside. This is 1 and g prime. And then I just wrote it again. I don't really know why. But I didn't like how I wrote it the first time. So if I'm plugging in a 1 here and here and here, okay? Right now I have to know what g of 1 and g prime of 1 is. So looking at my graph, g of 1 is 3, because that's just reading the point. G prime of 1 is negative 2. So that's 1, because x is just 1. 1 plus 3 on that one, and 1 plus negative 2. G prime of 4 times negative 1, and at 4 is 2/3. Let's go! We're balling up, man! Woo! No, boring. Alright, we're going to do these two both. Find one that says let f and g be differentiable functions such that blah 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 blah. Blah 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 blah. We're almost done. Perseverance. Let's do this.
I gotta go to work now.
You're good. Have fun. The rest of us are going to go to Menchie's, right?
Yeah.
For Spirit Night, and then we're going to go back and watch a movie in our PJs. Right, Mom?
Wait, what time does the next thing start?
Yeah, all day.
Oh, it's just all day. Okay.
It's already ready to go.
You gotta go fully Jaden.
I feel like
Okay. Guys, do you see how much is knowing your definition of chain rule? Like, so many questions are knowing your definition of chain rule. How do I take the derivative of f of g of x? F prime of g of x times g prime of x. Right? So many questions about that. Now, at 1, f prime g of 1 times g prime of 1.
Oh, that's what I said. I said,
Okay.
I you know.
Can you guys tell me what g of 1 is?
3.
3. Alright, cool. So the final thing will be f prime of 3 times g prime of 1.
G prime of 1 is negative.
G prime of 1 is negative 3, and F prime of 3 is negative 5. 15. Very good. Okay, now I do want to do that one because we were laughing at the exclamation points, but now we're gonna. It's like, who's laughing now? Let's do 4 derivatives. First derivative. Okay, now, I'm going to give you a little hint. I'm not going to put that 4 and that 3 together.
Why not?
Because then it's going to make a 12, and it's going to get bigger and bigger and bigger, and I have to figure out what that is. I don't like that. Okay? But do you guys see where the 4 came from and where the 3 came from?
Yes.
Okay, so that's first derivative. Second derivative, 4 times 3 times 3, and then another 3 because of chain rule again. Right? Because the 3 comes down in front, and then I'm just going to do my chain rules out here. Is that cool?
Right, so then at this point.
I mean, I think so. Let's just keep going. So if I multiply that down now, it's 4 times 3 times 2 to the first, and then 1, 2, 3. And then, if I bring this down, right? You guys following me?
Yeah. Yes.
Let's go. 4, 3, 2, 1. 2 plus 3x to the 0 times 3, 3, 3, 3. So what is it? C, not D. Yes, C. Because 4 factorial is where it's the 4, 3, 2, 1. And then I had 3, 3, 3, 3. And then to the 0.
Why do you keep the factorial?
It basically just means if I put a factorial on something, 5 factorial is 5 times 4 times 3 times 2 times 1. So when you see 4, 3, 2, 1, that's your factorial.
You can't get rid of constants that are multiplied by x.
Let's see if I can find a real winner.
That's a winner right there.
Because it's being multiplied by the x, you can't get rid of it.
Okay, there's actually 2 questions I want to do. I want to do these 2. Okay, you guys, you can do this the long way, this one on the bottom right here. But there is a log property that you can use that will make this so much easier. What log property can you use?
Birdie rule.
Can I bring that out in front?
Birdie rule.
What's it called?
The birdie rule.
The birdie rule?
Have you not seen my thing about it? I made a movie about the birdie rule. I'll show you. It's in dead.
Can you send it to me right now so we can watch it at the end of class?
I need your Chromebook.
I didn't bring it.
Jacob, it's on YouTube?
On your YouTube channel.
Alright.
I have a Chromebook, Jacob.
Alright, give Jacob the Chromebook. We have to look at birdie rule. Okay, the 1 half should come down in front, and now you guys, the derivative is so much easier because the 1 half stays there. And the derivative of ln is what? 1 over times chain rule, negative 2x. So which one is it going to be? I mean, the 2's cancel out, right? So negative x over 1 minus x squared. Oh, man, I didn't even know that this question was going to be this complicated. Okay, the answer's not there. What do we do? Assume we did something wrong?
Yes.
No, we don't do anything wrong, never. We're brilliant, we're amazing. That answer is there, actually.
Wait.
Oh, yeah, just negative goes.
It's B.
I knew it.
Mean. Because they took it went boom, boom, boom. That's
I don't know.
mean. That's pretty freaking mean. Okay. This one. Once again, there's an easier way to do it than ln and quotient rule. There's an easier way. There's another property. Jacob, do you have a name for this property?
Birdie rule. It's the same. Birdie.
This is birdie? I don't understand. It's a different property.
This is the minus thing.
No, because it's something to the power of something.
No, but where we're dividing, we subtract.
No, it's x squared minus 1 to the power of -1. You bring the negative outside.
Okay.
Well, it's the same, but no.
All right. But you guys remember how when you divide, you subtract? What's the derivative of ln of 1? 0. What's the derivative of ln of x squared plus 1? 1 over times 2x. Sorry, I didn't mean to write x squared. Times 2x. Nice. Hey.
Your password is saved on her computer.
Ooh.
It doesn't matter.
One more just because it's so good.
Oh, no.
I want to see if you guys remember this. I think you guys know more than you think you know. I don't know. Do you feel confident after coming to these? You feel better or worse?
Better.
Okay.
Not great though.
That means better though. 5 to the something. Do you guys remember how to do the derivative of that?
It's like log this thing and then it's just.
It's rewrite it because it's like e to the x. It's e to the x. But you have to do ln of the base and one more thing.
Chain rule.
Chain rule. 3x squared. So that's out of a 5 and ln 5. So I can already get rid of that and that. 3x squared.
Oh, that was my guess.
And on this, I feel like you could actually guess pretty well, even if the only thing that you know is the derivative of that is 3x squared. Because I've like narrowed it down to those two. And then maybe you'd remember, oh yeah, ln 5. Woo! Alright. You guys can work through any more of these that you want. There's answers somewhere for the questions at the back. What was this? Unit 3. Did I already show you the answers for Unit 2? That's Unit 3.
Wait.
I mean, honestly, if we get to a point where you guys need more points to get your A, do some of these, and I'll give you more points, you guys. Now I just love throwing points at you.
I still, okay.
I'll get points for comments.
Yeah, we got 100 points for Jacob getting something wrong.
It was like 100.
Wait, how do I
Play
send it to you?
money. It was like play money.
How do I send
Did
it to
somebody literally eat all the M&Ms out of this?
My brother would.
Who?
you? Just Mitchell, how do I send this to you?
Do you have the birdie thing? Can you email it to me?
It's glorious.
All right.